Hello everyone. Now in this session we are going to see what are the different data types that we have and the different variables that we have in Java. First we will discuss about what is data type. In the name itself it is telling that it is one type of data. For different data types it has different behaviors. Suppose if you go for int, it has 2 bytes of memory. If you go for float, it has 4 bytes of memory, double 4, like that. Every data type has different properties, different behavior. Generally we have two types of data types. One is primitive data type and another is wrapper object. Primitive data types are int, float, double, char. These are primitive data types. Wrapper objects are nothing but wrapped form of primitive data types are nothing but wrapper objects. If you wrap primitive data types, it will form wrapper objects. Now we will see where we will use wrapper objects instead of primitive data types. Here we have one method which accepts object form. Now I am going to pass a value here. For that first we have to create object. By using this object I am going to call that method. Suppose if I pass primitive data type value int a equal to 10, it will show some compilation error because this method allows only object. At that time we will wrap this primitive data type by using integer class. Now we will print this value. It prints 10. Here what exactly happened in the sense, here instead of passing primitive data type we pass it as an object to this method because this method allows only object data type. Okay, this is the main usage of wrapper objects. Now we will see what is variable. A variable is nothing but container. Why I am telling this? Because container has some memory space. If you discuss this programmatically, container has some memory space. In that memory space we can save different values, different type of values we can save. Suppose if we save a b c, that is a string type, and if you say 1 2 3, that are nothing but integer types, we can save any form of data. We will discuss about this variable pictorially. See, let it let this one will be a container. Let it be, it is a container, and in this container we are saving a value 8. Okay, and for we have to give some name to this memory space, so we gave x. This x is nothing but a variable. This value will differ based upon data type. If it is a int, we will save integer type of values. If it is float, we will save float data types, I mean float values. Like that, these values will differ based upon the data type. Okay, now we will see what are the different types of variables that we have. First one is instance variable. Second, static variable. Third, local variable. Okay guys, now we will see what is instance variable. If you declare any variable inside a class and outside of a method or particular block of code, then that is nothing but a instance variable, and this instance variable should be non-static. But we can apply any type of access modifier to this instance variable, but we can't apply to local variables. Okay, once we will declare instance variable here, int instance equal to 8, we will give it as 8. This is nothing but instance variable. The scope for this instance variable is throughout this class, and memory space will be allocated to this instance variable based upon object creation. If you create object, at that time memory space is allocated, and if you if you destroy that object, at that time memory space will be destroyed for this instance variable. Suppose if we create 3 objects, here we declare 3 objects. Okay, at that time this instance variable will be available in these 3 objects. This image is available in object 1, object 2, object 3. If you change, I will explain you with one example. So object 1 dot instance variable. Okay, now we will change this object value, object 2 dot instance value equal to 10. Okay, I gave it as 10. Now I am going to print this value, object 2 dot instance variable, and finally object 3 dot instance equal to 12. This is out object 3 dot inst. Now I said that this variable image will be available in these 3 objects. Now we will see how that value will come. First sysout, that value is 8, and for second sysout we changed that value to 10. So in object 2 image, that value changed to 10, and in object 3, that's in that instance value image is changed to 12. Like this, memory allocation will happen to this instance variable. See here, pictorially I represented for object 1, one separate image for instance variable is available. For object 2, separate image. Object 3, separate image. Now we will see static variable. Static variables are also known as class variables. Why these static variables are class variables? Because these variables are related to class. Memory allocation will happen during class loading, and for instance variables, memory allocation will happen in heap memory. Dynamically it will happen, at runtime it will happen. But for static variables, at class loading, while class loading, at that time itself memory will be allocated. And here, how many objects if we create, it refers to same image. See here, we created 3 objects, and that refers to same memory. That data will overwrite. Suppose if I declare this variable as static, now it is a static variable. If you print, at first that value is 8, 10, 12. uh, yeah, instead of this example I will explain with another example. Now we will print with object 1 instance everywhere, but here we are assigning value with object 3 instance, object 2 instance, but we are printing with object 1 itself. See, because 8, 10, 12, 10, like that this output came. So finally what I am going to say here is, how many objects if you create, all that objects will refer to same image. But in instance variable, how many objects if we create, that many images of that variable will form. See here, this is what I said, and remaining all properties will be same as instance variable. I mean, scope of the static variable is same as instance variable. Okay, finally we will discuss about local variable. A local variable is declared inside a method or particular block of code, or else inside a constructor. Memory allocation for local variable will happen whenever if we call that particular block of code, at that time memory allocation will happen. And if that flow, I mean if that flow of that method is completed, I mean that method execution completed, at that time memory space will destroy for this local variable, and we can't apply any modifiers, access modifiers to this local variable. See here I declared int b equal to 11. This is instance variable. Whenever if we call this method, at that time memory allocation will happen, and if that flow crosses this method, at that time this object, this instance variable, I mean sorry, this variable will destroy, and we can't apply access modifiers for this. See, it shows compilation error. This is about variables and data types in Java. For more videos, please subscribe to this channel and keep in touch. Thank you very much.